When we're talking about work and power, work is going to be a force in a given distance. I can push something as hard as I want for as long as I want, and if it doesn't move, according to this definition and the equation that goes with it, I have no work that's being done. The equation that we use here is that work equals force times distance. Work is measured in joules, and a joule is a newton times a meter, which you see here in this part of the equation if you multiply those together. Joules will show up anytime we're talking about work, energy, heat. It goes over a lot of different situations. So work, the amount of work that's done, is going to be related to the force, how much force you've put on it, and the distance. Now the force needs to be in the direction of the motion. So if I have a box and I'm pushing it that way, and I go from here to here, and here's my force and here's my distance, I have done work on that box. I've moved it a certain distance with that force. However, let's say I pick that box up and I'm pushing up on the box with my arms so I can carry it, and I'm holding that box up while I'm moving that way. The force is not in the direction of the motion, and so there'd be no work being done here. The only time you have work is when the force is in the direction of the motion. And work is measured in joules, which is newtons times meters. Now the other part of what we have is this idea of power. Power is going to be work divided by time. So you can do the same amount of work as somebody else, but if you do it faster, you've used more power. Power is measured in watts. And watts is also represented with a W. Here's where things get a little bit goofy. Power is measured in watts and represented with a W. P represents power. A W, as your variable, represents work. It's measured in joules with a J. So you have to pay really close attention. If W is your variable, it's work. If W is your unit, it's watts, and it's measuring power. So pay close attention to these two pieces. So with these equations, you have a couple of different situations. Let's say, for example, one, you have some cart with 500 newtons, and it goes for 10 meters. Cart is pushed with 500 newtons for 10 meters. Calculate work. Well, this is where the 5 steps still becomes really important. Not because you can't make the calculation without it, but because the physics depends on what you're actually dealing with. So force is 500 newtons. Your distance is 10 meters, and you're solving for work. Work equals force times distance. And so you have 500 newtons times 10 meters. 500 times 10 is 5,000 joules. That would be a complete situation here. We've done other equations that look like this. We've had we've had F equals ma, we've had P equals mv, we've had distance equals speed times time. There's lots of situations where we're just going to multiply two numbers. However, the physics behind it is shown in your variables in the correct equation and in the correct units at the end. So this would be an example of a problem just involving work. A lot of times we'll have problems just involving power. Again, power includes the time that you have to do that work. So you do things faster, you use more power. So example 2 might look like this, where you have a car uses 15,000 watts. Big, huge amount of watts there. So this is our power, and it does, I don't know, let's say 90,000 joules of work. Calculate the time. Well, you know that 15,000 watts is your power here. So power equals 15,000 watts. And we have 90,000 joules for our work. We want to find the time. We know that power equals work divided by time. You have to be able to rearrange for time in this situation because you know the power and the work. So to rearrange for time, you have to get time by itself, and it can't be on the bottom of your equation. So the first thing I'm going to do is move time to the other side and get it off the bottom. So I've got work divided by time, and the opposite of that is to multiply it. So I take work divided by time and then times time, and I cancel out the times here and do the same on both sides. So if time times power equals work. Well, I still need time by itself, and currently it is being multiplied by the power. So I'm going to divide both sides by power. I cancel out the p here. It was t times p, so I do the opposite. I divide. So I have time equals work over power. Time equals work over power. Well, now I can put my numbers in there. I've got 90,000 joules over 15,000 watts. 90,000 divided by 15,000 gives me 6 seconds for the time that I have there. And this would be a situation where I just have power, work, and time. Reality is, though, that between these two equations, you kind of have a third. So you have power equals work divided by time, and you have work equals force times distance. So if I take and substitute this in where work is, I end up with power equals force times distance divided by time. A lot of times you'll get situations like that where you know 3 of these 4 variables and need to solve for the other one. So, example 3, let's do that. A cart has 500 watts of power. It runs for 10 seconds and goes 100 meters. How much force was used? So you know that you've got 500 watts of power in your cart. It runs for 10 seconds and it goes 100 meters, and we want to know how much force was used in that situation. So we put our variables over here. Power is 500 watts. We know that our time is 10 seconds, and we know that it goes 100 meters. D equals 100 meters, and we're going to solve for force here. And you could have any of these 3 variables and solve for the 4th one. So we know we have P equals FD over T. We're going to solve for F. First thing I want to get F by itself, so I'm going to multiply both sides by T. And bring that over to the other side. So I have T times P equals FD. And then I want to solve for F by itself. So I'll divide both sides by D. And I cancel that out, and I'm left with F. The force is the time times the power divided by the distance. Well, the time that I have here is 10 seconds. The power I have here is 500 watts. And the distance is 100 meters. So it's 10 times 500 is 5,000. Divided by 100, force equals 50 newtons. So 3 different situations that we have. Example 1 that we looked at, we only had work on its own. We had work equals force times distance. We walked through. We didn't have to rearrange in this one, and we solved for our work in joules. Again, the 5 steps show us that it's not just like, hey, I have 2 numbers, I'm going to multiply them. It shows us that you know what things mean, what you're solving for, and how to get the correct units that go along with it. Example 2 that we had was dealing with just the power equation, power equaling work divided by time. And then in this situation, we had a power and we had work, and we needed to solve for time, so we needed to do some rearrangements. And we came to that the time was 6 seconds. given the information that we had in front of us. And then the third part is where we have the two equations combined. We have power equals work over time, and we substitute in the force times distance there, giving us this equation that has 4 variables. In this situation, we needed to solve for the force, so we rearranged over to force equals time times power over distance. When we put our numbers in, we were able to get that 50 newtons was our force that was being measured there.